BSS BSS solution is basically software distributor. We are dealing in the construction industry software since last more than 11 years, and we have more than 4,000 odd customers across the India, right from a north to the south, east to the west. At every corner of India, we have a client. We have a office based at Nagpur. Basically, we are into the software sales and support. Uh, Many of you might have heard about the CYPE as a structural designing software uh, from one or the other sources. So today we are here to have a detailed information about the CYPE, a structural designing software. So CYPE has been at the forefront of the software development of AEC industries, and it is an ISO 9001 company and in existence since last 40 years. In last 40 years. Uh, CYPE has developed around 150, more than 150 tools to offer to all this fraternity, and they have more than 1,70,000 customers across the globe, including 100 countries. And they have a network of around 30 dealers to take care of distribution and support in all these 100 countries. Apart from these dealers, they have around 200 professionals who gives a technical support and helps in the development of the software to the clients spread over the globe. CYPE is available into various domains like architectural, MEP, structures, and even the project management. And not only this, CYPE offers a basic workflow like yeah, CAD or DWG or DXF file, but also it offers a free platform like Beam Server, Web Beam Server Center. So that is the unique feature of SIPE. We will understand this later on. Uh, SIPE workflow integrates highly with OpenBeam, providing easy learning curve rather than a very easy to learn software. And also the projects can be incorporated with your AR or VR technology, which is latestly used by many of the people. SIPE is more focused on the design and analysis, and it incorporates analysis code across the globe, including India's code, that is IS code. We call it as an IS code. Those are also incorporated in all the models of SIPE. Site makes sure that all the project's technical reports, drawing, bill of quantities are deliverable not as per the engineer's requirement, but also the requirement of manufacturer or even for the authorities, concerned authorities. Site structural solutions can design and analysis reinforcement, concrete, steel, composite structure, walls, beams, slabs, foundation, and so on. And SIPE normally helps in optimizing the construction material to the fullest. And SIPE can provide you the detailed plans and even the detailed shop drawings. Uh, in fact, this is the just brief idea about what SIPE is. So, without any further delay, I request Ms. Sonsols to take over the technical session for the SIPE. Thank you
Thank
very
you.
much.
Thank you, Mr. Sandeep. So please allow me to share my screen.
Thank you, Mr.
Uh,
Sandeep. Yes, you can share your screen, Sansoles.
Thank you. Can you see it? Can you please confirm if you can see my screen?
Yes, we can see your screen properly.
Perfect. Thank you.
Thank you.
Please, I would like to, before I begin, my name is Sonsoles. I'm a civil engineer and I work for the technical support department. I would like to remind everyone that the chat is available for any questions to be submitted. So even though I'm going to be sharing a lot of information, please don't hesitate to ask any questions you may have on the chat. And I'll make sure to leave some time at the end to answer the questions, okay? So I would like to begin by coming into our website. This is CYPE's website. Let me go back to the 100%. So here in CYPE.com, you will find solutions for professionals. Today's main matter is our solution for structures, and I'm mainly going to speak about two of our key softwares of structures, okay? If any of the others come up or the questions or anything, I will answer, but the two that I'm going to demonstrate are CypCAD and Cype3D. So what is the main difference between CypCAD or Cype3D, or in which software we will start analyzing which kind of structures? Well, our CypCAD is the solution for story-like buildings. Okay, so story-like buildings are mostly subject to mainly horizontal and vertical forces, and that's why these types of projects that you can see here, or any high buildings, basically any story-like building will be preferably done in SciCAD. But we're also going to speak about Cypher-D. And the thing is that in both of them, we can insert elements, both reinforced concrete, timber, steel sections. Both, all of these materials are available in both software, but the main difference is that CypCAD is mainly for story-like buildings because of the interface that I'm going to show you in a minute. And Cype3D would be our goal if we were be to design any other structure that is more 3D, that is not just vertical and horizontal, but more of a 3D structure, which could be any of the ones that you're looking at right now. Maybe a warehouse is one of the main structures that we analyze in Cype3D. But let's not forget that both of them can be combined, and I will demonstrate that in this session. So without further ado, I'm going to begin speaking about SciCAD, and then we'll move to Cype3D. So to begin this demonstration about CypCAD, I created this little structure. It has Cype on it, but I would like to demonstrate here in this structure the option for the columns. So you will find that CypCAD is divided into 4 tabs. Usually the tabs in the software are in the order that should be followed to generate the structure. But here in the first tab, we find the column definition. This is where we would start adding our columns and creating the levels that we're going to see in a minute. So which types of sections or materials or which types of columns can we insert in CypCAD? Well, we will find, let me demonstrate the 3D before we jump into the menu. So here in the 3D, I closed it very rapidly, but you can see different types of columns. So we could create rectangular reinforced concrete columns, circular shape, but this CYPE, this type is also created with a column, and I'm going to show you the option to generate any geometry of column that you would like in reinforced concrete. So then we will move to the steel sections, in which you will find, of course, hollow sections, the typical sections that you would find, this steel, this Y section. And then let's not forget that we can also insert composite sections. So for example, this other column or these other types of composite sections where the steel section is on the outside and the concrete on the inside, or both of them, outside and on the inside and filled with reinforced concrete too. So now that we have taken a brief look at the 3D, let's jump into the menu. And here is where you will find the possibility to insert these sections that we have. I hear this, it's not very loud, but this noise, if we can please mute our microphones so we can all see the sound would be clearer, please.
Yes, Mr. Vijay and Dinesh, can you mute your microphone, please?
Yeah.
Well, I will continue, though the sound is not going to be very clear. If everyone can please mute their microphones so we can hear everything clearer, please. So, as we were demonstrated, this is where we would insert the columns. So, started from the reinforced concrete material, we find that we can insert not only rectangular and circular, but that section that I was speaking about, the section generic section. So one can create based on a DXF DWG that is very much snappable. One could create any section and the software will insert that for us. So other material that we can find for the columns is of course steel. The software comes with a wide library of sections, but let's not forget that between this rollized section, build-up section with rollized steel plates and cold form steel sections that we will find the library for by clicking here and accessing any sections. We have sections from all around the world. If we don't find a section that we would like to insert, the user can hand manually insert any section by clicking on add, and the software is very much parametric. So one can insert their own section by giving the different parameters. Moving on to the next material, we find that columns in CYPE can also be timber. We have round bars, square bars, and rectangular bars. Again, one can create one if this section wanted is not in the library. And those composite sections that we were looking at in the 3D can be found here. So different types of composite sections as well. And the last type of column that we could insert would be with the generic material. So you can, if you have a material that is
So
either.
sorry to interrupt, Sansolis. I will request to all like and mute your microphones. That will be a better that it's please. Yes, Mr. Sandeep, please tell to all like if they can mute your microphones.
Dinesh sir,
Yeah.
please mute your mic. Ajit Survade sir also and Amit Melani sir also. अमित सर तुमचा आपका माइक थोड़ा सा बंद कीजिए अजीत सर आपका भी so that it will be clear for all.
Thank you very much. That I think it's much clearer already. Although I still hear some sounds. Maybe it's just that we don't know how to mute the microphone. Please, if you're watching this on Zoom, on the down left corner of the Zoom should be a mic symbol where one can click to move the microphone. At least that's for me on my screen. Okay, so I think I'm going to continue. Thank you very much for muting your microphones, and the columns that we can insert are covered already. So let's take a look at the results of this element, and then we'll comment on the other elements that we can insert. But since we have taken a look at the columns, let's see what types of results outputs we can obtain from the analysis of this element. So in this job, for example, in this project, I have selected for the reinforced concrete, the IS 456 2000 in the standard. Please, I forgot to say that on our website also in solutions, you will find implemented codes, and one can share it by country and see all the possibilities of, let's say, India and structures. You will be able to find the codes implemented in the software on our website. So for this structure, for example, I have used this standard for the reinforced concrete, and then for rolled ice steel, I used also this Indian standard. So I coming back to the comment in the results, I have switched tabs. Okay, the software, as I said, is divided in four tabs. The first one being the columns that we took a look at. The second one we will cover in the next structure, but is where you can insert the rest of the elements that form the structure, being like the beams, the walls, the slabs, whatever needs to be created. And the third tab would be the results tab. And here's where I can consult by editing the columns, these results. So based on the analysis ran with the Indian standard, you will find that one can consult the forces over the elements. In this case, the columns, we can see on screen the different forces, and we can see here that we can consult them by load case, meaning self-weighted load individually, or one can consult them by combination. So at all times, one before the checks are run can see what are the forces acting to understand the behavior of that the structure is having. So speaking about the standard checks, the code checks. Here we find these for this column, we can, and for any column, we can ask for the ULS check and ULS and SLS check report. So here, by clicking, you will find this report very complete. I mean, it's the full report on the column, divided by the different checks that have been run. For example, the ultimate limit state for shear of this column, and you can see how detailed this report is, meaning that if you have any doubt about what the software is actually giving you as the output, you can very much check here if the values are clear. They are very clear, so that you can check them. And the full report can be exported to multiple formats. So you will find this report. Usually, some other solutions or them in the market are don't give this full report, but here we have the full report. And based on the analysis, the software is also able to design the reinforcement for us. So here we have the 3D view of the reinforcement that the software has come up for with of the column. This reinforcement that we can see here on this table can very much be edited. So please let me move to one that is not passing the checks. So we can see here on the left the list of the columns that we have inserted in this structure. Some of them are displayed in green. Usually in all solutions, the elements that are displayed in green mean that they verify all the checks, the passing elements, and the ones shown in red mean that something's wrong with them, and that's exactly also for our solution. So let me move one moment, something that is bothering me on the screen. Sorry about that. And so this column, this composite section that I click, by the way, one can see where we're looking at on the plan view. So we're looking at column number 14, and we see that something's wrong with them. Let's check what's wrong with them. So I can choose to only display the values that or the failed checks. So the failed checks in this case tell us very loudly that the longitudinal transversal force reinforcement, in this case the longitudinal particularly, is not enough. So before we have the software, we have four of this diameter. Let's change the diameter of the bars and ask the software, maybe with 16 will already be enough. We can update without analyzing again. So if we click in update, in this case, these four bars in the corners with this diameter were enough. Coming back to another one that we took a look at earlier, maybe C3 or C. Yes, these ones, the stirrups can very much all the transfers um, and reinforcement can also be edited by clicking here. And we could add, for example, the acrostic here and here, and that would be very automatically also represented in the or displayed in the 3D view. So one first the software designs for us, but then we can edit and change whatever we wish. Also, the other results that we can ask for the columns is this list of checks undertaken for all the combinations here. And specifically, maybe for this one, we could see the equilibrium diagram for this section for the combination that we select. So we have at all times the results of the analysis. Another output that yes, we want to exit. Another output that we can obtain for the columns is the automatic drawing of and the detailing of the columns. So please let me demonstrate that without any drawing previously created. Okay, we're going to create it together. Here, if I click in add, I can access a list of types of drawings. One of them is the detailing of columns. So for example, if I ask not to for it to be overwhelming, these C5, C7 column detailing, the software will automatically create a drawing of that column. It will give us the detailing of the bar as well as this table, the quantities of the reinforcement of this bar. And I'm sorry, is there a question? Okay, thank you. Please leave all your questions in the chat unless they're very much related to what I'm saying. I will answer all the questions in the end. And but please feel free to ask also. I'm muting your microphones if you wish to do that also. And here's the bars bin disk schedule. And so yeah, this drawer, the great thing is that the software designs the reinforcement that can be edited and automatically generate the drawing for us. Moving on to other elements that can be inserted in CyCAD, let's move to this other structure where I would like to demonstrate that this combination of materials is very much possible without moving to another software. So here we see some steel and reinforced concrete columns as well as some steel beams. Okay, and I would like to actually speak about that. So the next step to column definition would be the beam definition. The tabs are very much named after what we can do in them. So in this other tab, we would insert beams, walls, and slabs. So what types of beams can we insert inside SciCAD? Well, any type of reinforced concrete beams, meaning dropped beams of very different types of geometry, also with variable section. We can introduce lattice beams as well as some types of pre-stressed beams with these types of sections. We will also find foundations beams, meaning that if they're in contact with the soil and we want to see what's going to be their displacement in Z, if they admit as subgrade modulus. And also, of course, as I demonstrated on the 3D view, inside the beams, we find the same sections that were available for the columns in steel ways, and of course the timber too. So those are the materials that we could choose for the beam. And the results that we can expect on the beams are very similar to the ones on the columns. So we could ask without inserting any or without going inside the result, specific result of any beam, we could ask here for the envelope of forces diagrams. So we could directly on screen display the different force diagrams of the frames on our structure. Yes, is there a question? Okay. So one can ask for the envelope to see it by locase or by combination, and they can be displayed on screen. But let's take a further look into the results of beams. If we come to edit any beam, let's hope there's one with some type of error. So we can see here in the beam editor the reinforcement obtained from the software. We haven't done this manually with the tables, the reinforcement tables that are set here in project general data. Here are the reinforcement tables for all the beams, the columns, the waffle slabs, whatever reinforcement tables we use, the software is going to use them to reinforce the elements for us. So if we take a look at the reinforcement here, we can see the different sections with their bars. Is this editable? Of course. If we come to here, everything that is the software comes up with is very much editable for the user. So one can edit, for example, the bars. Let me see. We could change the diameter of the bar, or we could change the longitude, um, yeah, so we could change this, not only the longitudinal reinforcement, but also see that we could also edit the transverse reinforcement, meaning what number of stirrups we have placed in the section. And also inside the beam editor, we can take a look at the same force diagrams. I don't know if the line is very clear. If, for example, the bending moment in Y is now displayed in this color, and maybe here is the shear force or diagram over the frame that we are consulting. So one can very much edit the reinforcement given by the software and can expect also a ULS check report, full report on the beam that we're looking at. So asking for the report, we can see the software runs minimal and maximal reinforcement check, the shear, for normal conditions, the torsion. We can see calculations of the sign of shear force because this structure that we're looking at now, not only has been analyzed using the India standard, but I also inserted wind loads and seismic loads with the software. So let me show those here in the general selection, general data of of the project, we find the possibility to activate with wind loading. And we have here for India, I selected the IS 875 Part 3 2015 standard. I selected the tributary widths of the different plants, and here we can ask for the map to see what is going to be the basic wind speed based on the location that we have. Even though we can select it from, we can take a look at the map and see which color. The user can also change the value to any other value and insert it manually. Well, here we can see that we have to adapt to the terrain category. We have to select the importance category for the cyclonic region. And then for the land orthography, although I have selected flat, one can go into much detail about what is the surrounding land or orography that we find to generate these wind loads very um, current very correctly. So also one can select with for the seismic and wind loading, we have second order effects which can be selected here. And for the seismic loading, I have selected IS 1893 part 1 2015 to 2016, sorry. Here we can see that the software is able to perform dynamic model, dynamic analysis, seismic analysis, and also static equivalent lateral force analysis. For the dynamic one, we have to select the parameters. At all times, we find question marks to help us fill those parameters according to the information that comes in the standard. And then we can select the for the estimation of the fundamental period of the structure based on the code, or the user can specify it manually. We can set the drift limits for our floors. So I have selected some, so we can see then in the report if there's something wrong, or there are some parts that the drift is not according to the limits that I have established. And then this is the limit of the stability coefficients, and the number of vibration modes considered in the analysis can be based on the code or specified by the user again. So again, for seismic forces, we can activate or take into account second order effects, and one can consult the design spectrum also from this menu. So with that data that I inserted previously on the analysis that I ran, I can come up to file and reports and take a look at some of the results before we so here we have, for example, the report on the justification of the seismic action, full report on the data considered, and one can clearly see all the values that are being used from the software. In this case, just 11 modes of were needed to pass a to move the 90% of the mass. So we can consult the full report. All of the reports that I will speak about on this demonstration can be exported to the same formats that I talked about on the ULS check report of the column. And another, for example, since I established those drift limits, here we can find in these other reports the drift between floors due to seismic action. And we can see each column in the different floors that the structure was divided into, and it gives me the absolute and relative drift, and it tells me if it passes or not the limit that I established. I here see some red that there are some there are some drifts a little bit odd about P9 and P10. Okay. Other types of reports that one can consult and that are very, one can consult for the job ratios of the structure, meaning we can obtain very quickly the what is the volume of our pad footings, our tie beams, which I will show in a minute, the beams that we were looking at earlier, what is the surface of all the beams. We can ask for this in different ways. So there are many, many reports. I think I talked about the ones that I were more interesting. Um, and so I thought about this seismic and wind loading because we were looking at the results on the beams. So let's go back to them for 1 minute, just in case I forgot to talk about something. I believe I already displayed the ULS check report for the beams too. So here, full report on the elements that we click on and the justification of the code check is ran. So, not in the edited definition, but yes, I would like to also demonstrate the types of drawings that we can obtain for the beams. So in this case, if I delete all the previous inserted drawings, we can generate together the frames drawing. So for example, we're in this first floor. I'm going to ask for only the beams in this first floor, not to have to be too overwhelming. We can ask for the reinforcement layout and the quantity summary and see what comes up in this automatic drawing. So we can expect to see the same results as we were consulting on screen previously in the Beam editor. The software automatically creates the views of the detailing of the reinforcement for the beams. And here's the bar bending schedule. Moving on to other elements, of course, in this structure, we find that we have beams, we have columns, and we also have slabs and walls. So let's speak about the types of slabs that one can insert in SciCAD. I believe mostly in India, and correct me if I'm wrong, it's mostly flat slabs. The use the habitual use for slabs, but we have other types in our software too. We have joist floor slabs. One can insert hollow core slabs, composite slabs as well, waffle slabs, and one of the things that we're going to comment about the foundation, the types of foundation that we can insert is that we can also here in the slabs find mud foundations. So in this case, my in this structure, I have used flat slabs, just flat slabs, and we could take a look at here in the results. There is this 3D view of the reinforcement of the entire structure, so we can see better um, the solution. Okay, so we talked about the 3D for individual elements, but we didn't comment yet about this 3D view. As you can see in this, for this structure, we can consult at all times the 3D of the reinforcement of the elements. We will also speak about pad footings and pile caps in a minute. So for the slabs, we can spec those results, and also very importantly for slabs, we can consult the contour plots. So here, contour plots, we will be able to to check the, for example, the displacement, the rotation in X and Y by load case, also by combination, and not only the displacements, but we can also ask for the ratios, the reinforcement ratios used in which parts, which is the zone covered for by the most reinforcement. We can ask for the, in the case of the mat foundations, for their ground bearing pressures. So let's talk about foundations, and I will demonstrate that in a structure that has a foundation. So here we see this other structure, and this one, the foundation was solved using a matte foundation, as we can see on screen. So here in the contour plot, we will be, of course, the matte foundation, whenever we insert it, we fix the soil bearing pressures and the subgrade modulus. So sorry, I'm not in the so one thing I forgot to comment is that CyPE is 2D environment, right? We're looking at in the results and in the beams definition all times at the 2D, although sometimes we can get the 3D. So one way to change between groups is this arrows right here to change one group at a time, or we can click here and go all the way to the foundation. So here I was speaking about the subgrade modulus that one can insert for the mud foundations and the soil varying pressures. So fixing those parameters when we come to contour plots in the case of mud foundations, one can ask for the ground bearing pressures, and they can be displayed here. The color bar that is in the bottom of the screen at all times is showing us the values. We can filter by maximum and minimum value. Let's say, for example, in this case, we only want to see between points 18 and point 19. So we say point 18 and point 19. And we can see the part that is between, sorry, point 19, 18, and point 19. Fix the maximum value. Okay, we can see the zone that is from 0.18 to the maximum value. And let's see other aspects that we can have on our structures. I will have to reopen that one because I keep just a minute, please. So this is our site menu, by the way, if you haven't seen it already. The same professional solutions that we are on the website that we took a look at earlier. These professional solutions are the groups of um, software that we have developed. So the same solutions is the same groups that we can find in the side menu. So let me reopen that those two last structures that I closed. So sorry. And here in beam definition, and I will reopen. As you can see, we can have multiple windows open at the same time. I will open that one and this one again. Okay, so coming back to this structure that we already spoke about, here I had the foundation solved with I will say it. Let me see, with path footings, right? And I would like to demonstrate or show other types of foundation that can be inserted. So we already talked about matte foundation and what type of elements can we insert also for the foundation. Well, we can find reinforced concrete pad footings, reinforced concrete footings, mass concrete footings, and also pile caps. It's very this in this case the results for the um, found the footings that I have on screen. We can ask for the results on any of them. So sorry, I don't know what happened. Maybe I don't have the foundation analyzed yet. I will demonstrate also that inside 3D. So please forgive me and allow me to move on. And in this same, in that same structure, I also wanted to comment on the types of walls. So we have spoke about columns, beams, and slabs, and already talked about a little bit about and the foundations. We will come back to that, but we didn't talk about what types of columns can be inserted in and analyzed in CYPE. So in this job, we find that we have reinforced concrete walls, plain stress walls with just um, one mesh of reinforcement, and also we find masonry wall. So those are the types of walls that can be inserted in this software. And here we come to results, and as for the results on the walls, we can see here in edit walls. That was selected as a shear wall. Sorry, I forgot to say that whenever we insert a wall inside cut, there is the possibility to say that it's going to be a shear wall. The shear walls are taken into consideration for the analysis of the structure, meaning they are going to be considered as a shear wall, but the reinforcement should be designed for the shear walls in our solution called Strubeam shear wall, which is specially designed to generate the reinforcement for shear walls. So in this case, since I had seismic forces, I insert this in this model as a shear force. Let me see if I had another, because I had a model in which those weren't yet shear walls. Let me see if it's this model. No, I already consider it as a shear wall. Okay, so beams, columns, slabs, and walls we talked about here in CypCAD. Um, Let me move to Site 3D to speak about our solution for 3D structures. And since we have to cover it, them both of them combined, we will take a look at SiteCAD later on too. So in this case, I have opened our solution for 3D structures. Remember, in this session, we were going to be covering SiteCAD and Site3D. So this is our other software, Site3D, in which the environment is 3D. So it's more or it's easier to insert these types of structures. Substructures, warehouses, we will take a look at some other types of structures too, but basically it's not a story like building, so it's this one in this case would be preferably done in Site 3D. So Site 3D, as we say, is 3D. The elements that we can insert here are bars. Bars can be of very different types, not only steel, okay? We also can find timber sections, concrete sections, aluminum here, and these sections inside 3D come with a little bit of editing, meaning that the I section admits also different types of, for example, in this case, haunches, simple section but with haunches. We have double welded in box option. We could add only a half section. We could insert lateral plates, and we could also have castellated walls with web openings, right, of different geometries. And so basically, the software is very much thought for 3D structures. When we insert bars, is based on bars and nodes, although we can ask for to see those bars and nodes, or we can ask to see the 3D representation of the bars, whichever is more um, used for or useful for us at that time. If we see, we can see that it's a 3D environment, but can be very much, we can create 2D view windows of the same structure. So maybe it's easier to take a look at some things or model. While modeling, it's important to be able to create 2D views as well. From the analysis, yes? Are there any questions? Okay, sorry, I thought I heard something. So from the analysis, what can we expect? Again, we have the possibility here to ask for roll steel already in the Indian standard, and also I have selected Eurocode. And from the analysis, we can expect to consult their reactions on the bottom of the columns, or the fixed the external fixity ends. We can also ask for the forces. Maybe for the forces, I will move into the 2D of the gable wall and display here analysis, forces. We can ask to see, let me place this window here so everyone can see better what we're selecting. I'm going to ask to display the envelope for the selected bars, asking for the values, and we might have to adjust the scale at some time, but basically we can consult on screen at all times the values, maximum and minimum, and also if we move the mouse along the bars, we can also ask in this case for the Excel force. We could also maybe ask for the moment in Y. Let me amplify that with the scale. So we can ask for the different types of force diagrams on screen for this, or we could also check the forces um, in the analysis. So one thing that Mr. Sandeep pointed out to you earlier was very much right. This software has some tools for the design. So there is one specific tool that would I would like to make emphasis on, and is our check element tool. So with this tool, one could have run the analysis and ask for any bar based on the series of section that we have selected, and the software will give us the passing sections from that series and will display which ones are not okay. So the software can design the section for us, and we can also fix the section that we want to use and ask for this design option to see if the element passes or not, or which section would be the first one to pass. According to that, we can also consult the ULS check report on the elements. So full report again on the bar that we click on, we can see here the maximum effective slenderness ratio. We can consult this resistance to axial tension. We can see combined bending moment in Z and a shear force in Y resistance. And so we can consult the checks ran and again ask for the full report on these bars. And we can consult this in so many different ways. I'm trying to think of other results that we can consult. Maybe here in analysis, we can consult the deform shape for this warehouse. We can consult the deform shapes and see the displacements by load gates. Here we can ask for displacement by different combinations. We can amplify this deform shape and actually watch an animation on how the structure is actually behaving. This is very helpful, at least for me in the technical department, because once every once in a while we get weird results and maybe it's because the bars are not well connected, and this deformed shape gives us very quickly which bar is odd, because it will the displacement will be totally odd, and we can spot that bar very quickly. So I have one important thing aspect to comment here is that the solution of SciCAD and Cype3D has inside of them implemented the ability to generate the design and check of some connections. So they have both implemented for stylized sections and for hollow forgot the name. Let me go back here one moment. It's hollow structural sections. Yeah, these other types of sections as well admit the automatically generation of the joints, which I'm going to demonstrate in a minute. But basically, you can see that the software will be able to create all of these connections and actually also give us the report on the analysis of those connections, both welded and bolted. So if we come back to our model, I'm going to go on and generate here as to generate the connections on this structure. We're going to answer yes, and it has automatically created 180 connections. Since they're just created, I have to perform the analysis of the design of those connections. And here in the design, I'm going to ask for them bolded, which is most typical in warehouse structures. And we could, without further ado, here click in joints and edit any of the joints apparently created by the software to consult the results. So how fast was that? With one click, we just solved the connections for this structure, this warehouse structure, and we can ask for the code check again of the connections. Here we find the list of the code checks ran. We can ask for the automatic detailing of the connection, so it generates automatically a drawing that can very much be exported to DXF DWG format. And we can ask also for the complete report, meaning both the code checks and the full report on the connection. We can here see that first display the drawing, and then it says it lists the elements that are form part of the connection, and then it starts with the code checks for the welds, and then for the bolts. So that is one interesting, very important feature of Cype3D. Also in Cype3D, of course, we can generate the drawings automatically. So we can ask here for the drawings, maybe of the 3D and the different, let's say, of the 3D and the gable wall that I displayed earlier, we could select to show or display some the bar length or the section type or the dimensions. Whatever we select is going to be shown on screen. Maybe the section type. And I click accept and click accept again. So the automatic drawings of SciCAD and Sci3D are automatic and also a little bit editable, meaning that they come with some configuration that the user can select. For example, if I don't want to see the axis on the 3D, I can ask for the real the drawing for with the real section already displayed on the screen. So here we see the drawing. In this case, with the real section, you can already see the connections there. And also in the 3D view, we can ask for the complete 3D view of the structure, and we will see how everything is integrated together, meaning that we can see here the bolts and the welds, the different sections. And we can not only create, of course, warehouses, the flexibility of the 3D structure software that we have is, of course, very flexible. So moving on to some other important aspects, let me display another project, in this case, this footbridge, in which the interesting aspect is that we have used the backlink analysis. So I didn't point out when we were speaking about the different bar description and everything, that we're able to perform three types of nonlinear analysis. The first nonlinear analysis case would be that we can insert bars that have a behavior of only tension, meaning that they will only work if they are in tension. In every other combination that those bars are not in tension, they will not affect, um, they will not affect the analysis. The other one is that when we select the fixity of the external fixity of the elements, we can check and see that they are elastic. So second nonlinear analysis that we perform is that on the external fixity, we can give them different behaviors, meaning only more only work when the displacement is positive in the positive direction, or only when it's negative. These it's actually a subgrade modulus is going to work. This K is a subgrade modulus, only work in the negative or positive direction. So the behavior expected on those external fixities is that. And the third type of nonlinear analysis that we have is that on the shells. So we have bar and nodes. Basically, any soft structure or any 3D structure can be discretized in those types of elements, but also we have shells. So shells is our element to create surfaces that are discretized by finite elements, and we can not only tell it the thickness, but we can add this third type of nonlinearity would be only act when the if we place a shell in the on the soil, then only have this behavior, this only use this upgrade modulus when the shell is moving towards the ground, not on the other direction when it's compressed. So shells can be concrete, rolled steel, cold form steel, and then generic materials. So very flexible. We will see also a this structure has these shell elements already here. We inserted with this option of the shell, and here you can see the parameters, but the results can be checked basically here in the deform shaped inside 3D. We can ask to see the contour plots on the shell. So here we can consult the displacement, the forces, and the stresses over these shell elements. Of course, the displacements and the forces is of the forces again axial in y moment. So yeah, those shell elements are part of Sci3D as well, and are very much used in some 3D cases. And um, and the other part where we use for the nonlinear analysis, the software, the nonlinear analysis is ran with an motor like analysis engine developed by the University of California. So OpenSys is the tool that the analysis engine that we use both for the nonlinear analysis and for the backlink analysis that this software is able to perform. So for example, in this footbridge, I selected this structure to demonstrate the backlink analysis. So I'm only going to draw the elements considered in the backlink analysis, which is of course the top R chord and the diagonals here bracing it. So if I consult the results on the analysis, I can here see in backlink contour plots for the active window, we can display the different modes of the backlink. So in this case, we are looking at the first mode. If we select two modes, we can clearly see the backlink behavior of this top chord. And yeah, that's the backlink analysis option. And yeah, we already spoke about the shells, so let's see also the results on maybe this dome. And this dome is done in aluminum. So let me describe the bars right quick. So we could see another material that is not steel, but is in this case we used extruded aluminum. Um, Here we can ask for the same results as any other one. Of course, if we click on check elements, it will show display in green all the elements that are passing. And from the list, it will show us the different code checks for the two, in this case, two sections that we have in this series for the aluminum. And the important thing about this dome is that it's a very 3D structure, and it serves me to now speak about how these two software that we have been looking at combine together. So CyPE has the possibility to bring into itself substructures, or to put it this way, 3D structures. So in this structure that we took a look at earlier, you can see some parts that are steel. Maybe we could have done them with CyPE, but it's easier if we create them in a 3D environment and then bring them here. So this is one example, and very maybe the ones that are here. By the way, this option that I'm commenting on about being able to bring 3D structures, we can come here. Is the option is right by the stairs menu. It's called integrated 3D structures, and as you can see here, there's the option to import job from Sci3D. So maybe these soft structures were very impressive, but let me demonstrate other combined structures that we could solve with the two software together. So in this case, we're looking at this elevator structure that also has this footbridge to go into, for example, part of the city that is higher than the ground. And the walls and these slabs were analyzed using CYPE, and this steel part is the 3D structure. Let me demonstrate. If we go to the upper level of this, let me see if it's one down. And here I can add for the list of integrated structures, and we can take a look at it. Let's say edit. So I hope this is not going to be too complicated for the first time that we take a look at the software, but is very much what we're going to see in a moment is a Site 3D window inserted in CypCAD, so we can edit the 3D structure as we are in CypCAD. Let's maybe demonstrate that on the, let me close some of these structures as we are finishing. And by the way, if someone can please already read out loud to me what are the questions that are on the chat, I will appreciate it. Since we have, I believe, 12 minutes left, I would like to begin, even though I'm going to continue demonstrating this connection between SciCAD and Site3D with different structures. Are there any questions? I'm sorry, is there anyone there?
Yes, Sansolis, we can hear you.
Okay,
And we
sorry,
can
I don't know
clearly.
how far we lost each other.
No.
Where did I stop sharing?
You were showing the integrated structure about the tower
The
where we
gra-
had the,
okay,
and after that you close the program to talk about you are closing the CypCAD and you will be coming back to the integrated structure to show them again.
okay, yes, thank you. So you could, we were left in that part. Are there
Yeah.
any questions in the chat? Can you please read them to me, Himanshu, please?
Yeah, one Mr. Vishwanatham asking about the software capacity to design a bridge.
Okay, the software is ready to design some food bridges. The bridge itself, it's not the main purpose for the software. But yes, as you could see, we could create some food bridges, and they have been very much done. But bridges is not the main focus for the software.
And
Okay. Mm-hmm.
there's one more question. I think it is Mr. Suhas. Is
Yes.
there? Please let me know about any real-time structures executed where and when. Uh,
Okay, thank you for that question. Yes, that was perfect. So I forgot to mention that you can consult on our website the project gallery. Are the projects that have been executed using SIPE and that are already real structures, so you can see where they were executed. For example, this Infinium Tower to 22-story building in Kelp. And we have here this I guess it's a petrol well or some sort of steel structure, right? For apparently a petrol industry in Bogota, Colombia. Then we can consult maybe this one. Hold on. Here we see in Bolivia this Altos del Sur. Um, maybe I, d- I forgot if we could by clicking. Okay. So yeah, you could consult in the project gallery on our website what types of projects have been done, but we have all types, especially in the city where CYPE is located. In Alicante, there's a very near city nearby that is called Benidorm, and that is full of skyscrapers, and most of them have been done using CYPE. Yeah, I don't know if there are any other questions, or he mentioned maybe is there anything that you can think of, or anyone that I thought about saying that is important?
No, I think you can continue. We don't have any other questions.
Okay, so that is it for my part. Maybe we'll demonstrate if you have a few more minutes that ability to edit Sci3D structures inside SciCAD. So if I go back to this sets is being used. Where is it? Here, the composite. So if I ask here for this list of structures that we had on this composite structure, okay, we had some soft structures here, then we can edit them. And it's very soon for, of course, anyone to be able to to recognize that this window that has opened right now inside SciCAD because it has SciCAD logo is exactly the same menus that we have inside 3D. So too early to notice that, but yeah, the Sci 3D structures that we analyze inside 3D can be very much brought to inside SciCAD, and then inside SciCAD we could choose to modify them or do with them whatever. Maybe this other example is also very good. So here we have a dome of a stadium that was done with Sci3D, and then we brought it as an integrated structure inside on top of SciCAD. Even though inside 3D we can also add these reinforced concrete columns, but maybe whoever designed this has decided that these other parts of the grade, the benches were going to be designed using slabs, so they created the bottom part of the structure in SciCAD and then placed this dome as an integrated structure inside SciCAD. Another thing that I would like to comment and demonstrate and that was left from earlier is the foundation analysis on on the um, the footings and the pile cups. So here we can see that if we run the analysis inside 3D for these, we're gonna let it design the footings for us, and the software is going to come up with the results for these pad footings. So one can select between centered or square footings, rectangular center footings, some types of tapered footings. And most importantly, the software will give you the checks, code checks on the footings. One can modify everything. We could change the dimensions of these and ask for the software to redesign the reinforcement, right? I have changed a little bit the 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 geometry. So if I click here on design and click on redesign, The software will redesign for us the reinforcement, although we could have changed it manually also. And then we can ask for and show us again the full report on the code checks for this pad footing, as well as we can consult here the 3D view. So the footings that or the foundation that we could insert is not only for single column um, footings, but we could also here in insert, we could start with the reinforced concrete. We could select multiple starts, and if we say it's going to be a center rectangular footing, we can click two columns and say, okay, they too should form a a um, a and one single footing, and we can ask for the design again, and the software will design that other footing for us. So if we now edit it, we can see the results for a multiple star footing. And I wouldn't like to forget to insert at least one pile cap. So here in pile caps, we can select also with single start and multiple start, and we can choose the number of piles under the pile cap. And when we say we're going to generate a pile, of whichever circular or square section, and we give it the width and the pile carrying pressures, then we can insert it and we can analyze it as well. Okay, with this, I would check maybe in the 3D view. We can see the reinforcement for the pile cap and ask for the code checks. We see now, in this case, it warns us if there anything wrong. Here we see the tie and truss model, that there's some ties that are not okay. We can ask for this tie and strut model as well here, so we can better see the forces acting on the pile cap and better understand the results given by the software. Okay, that really is it for my pad. Let me share my screen, and if there are any left questions, please ask now.
I think I would encourage Mr. Sandeep to ask our viewers about their doubts and questions. Mr. Sandeep.
Yeah. किसी को कोई डाउट होगा तो आप पूछ सकते हो. Anybody has any doubt, you can ask. Any doubt regarding anything up till now we have seen?
Okay.
You can unmute your mic and you can ask.
Okay. There is some questions in the chat.
Yeah.
Mr. Kailash.
Yes, for
Yeah.
price we have like best offer for the all attendance. Mr. Sandeep, you can provide our offer for attendance.
Yeah. Actually,
So
the
buying
price.
visually or what your wish. Yeah.
Yeah. Basically, the entire structural suite consists of four different applications, that is CYPE-CAD, CYPE 3D, CYPE Connect, and Stu Steel. These are the four things which is combined together, and it is costing very reasonably priced in India. It is costing 4,40,000 plus GST. But those who have attended today, everybody will get a 20% discount on this base price. The only thing is that this discount will be available for 1 month only. So today is the 9th, so it will get closed on 8th of June. So anybody who is purchasing before 8th of June will get this offer 20% by default.
And there is one more question, that is, how does this work for the Pro Flex structures, Sansolis?
Can you please, sir, clarify, Nikita, what do you mean by Proflex? I don't get that question.
Nikita, you can unmute yourself and you can ask. Um, also,
Trustless. Yeah, I believe we didn't. Uh, we had some trustless structures, right? This doesn't have a truss; it's just beams and bars or some others that we saw. Maybe I'm not
uh,
understanding
she
right.
I think she is concerned about the PEB, what we talk about pre-engineering frame structure. That is what we generate with the portal frame generate. Portal,
Yeah, but it is without the trusses.
yeah, without
Yeah.
the
So
trusses.
entire sheet is whatever the shape they want, they can use the bend sheet, and then entire structure is built on that. That is what is Perflex. Am I right, Nikita? Yes. That is what.
Can you repeat that, Sandeep? Sorry.
Yeah. See, it is basically the structure without having any roof. That is trusses. No trusses. Only they have a sheets over the roof, and all the basic structure remains same.
Just some loads over the roof.
No, they don't have any roofs at all. It is the sheet,
Oh,
bent sheet.
but any type of structure can be created. Yes, it can be.
Yes. That can be created. That is
Uh,
perfect structure also can be created in site, because
ru-
anyway the sheet bending of sheet and all will be done by the company. You will have to give them the detailed structural
Uh,
design, and then only they
I,
will be able to give it to you.
I think Sansola, she is asking whether we can introduce anything on the roof without any bars. That is introduction of the cells. A
Shields
lot
on
of
the
shell,
bars.
yeah, no,
Oh
cells on
yeah,
the roof. Yeah, just we have to create the nodes and introduce the shells on the roof, and it will be without any bars.
exactly. You can model inside 3D using bars and shells. The shells don't need to be on top of any beam like this. You can have the shells also without any bar. The shells have the same possibilities as the bars, meaning that we could have a model that is only. Let me delete all the bars.
And now the next question is, can we also design steel connection like weld and bolt on it? If then,
With the
yeah,
bar, with the shell.
no, it's a different question. Yeah,
Okay,
we can do the Proflex structure. We can do that.
okay.
And
So we delete these notes that are a little bit off.
you're not sharing your screen.
No, okay. Hold on. Thank you for letting me know. Um, let's share my screen. So coming back with the model with just the shells, okay, the shells could be directly either placed on the ground by setting shells. Even we say um, describe their external fixity, and we say, okay, this side of the shell is has external fixity, and we say whatever, is it fixed, is it pinned, is it whatever we select. So yes, it works the same even without the the beams underneath, or if you wanted to, you could place a column only. They don't need to rest on any element particularly. So yes, the answer is yes. One can create Proflex structures inside 3D.
And, the next question is, can we also design steel connection like weld and bolt on it? And if yes, then how? Or how we will have to arrange another session, but yes, we can do that.
Arrange with the shell.
No, it's a different question about the connection. Steel connection like welded and bolted connection. Can we do that?
Sorry, I don't see you guys and I don't see the questions. The
It
questions
is in the
can.
chat.
Okay. Can we also design steel connections like weld and bolt on it? Oh yeah, the actually the bolded connections had a little bit of bolding in them, meaning they're not just all welded, bolded. Sorry. So the parts that need to be welded here, where you can see the weld, you can actually ask for the results on the side welded, or we can choose to design this connection welded. For example, completely welded, and we will see how those bolts disappear, or you could design it bolted connections. So of course the parts that cannot be bolted anyhow to the plates, for example, in this case, need to be bolted, welded. Is that the question?
Yes, I think that
Okay.
answered one. And also, if anyone has any other questions, Mr. Sandeep, if you can ask. Okay, so I think
There is a one more question: how to download the software?
Okay, that's a very good question. So, the information that the Sandeep shared earlier is very much true. We have a platform called BIM Server Center, in which anyone can register with just an email and a password. Our software can be downloaded by going into this platform, and here at the store, you will find all of our solutions. The two that we commented on today were our CyPCAD and Cype3D. And this is where um, one could download them.
Even you can go to the site.com, and then from there also you can go to the Beam Server Center.
Exactly. If you come, thank you, Sandeep, Mr. Sandeep. Here in Solutions, if you click on download area, they will submit it to this. Our latest version published right now is version 2025D. And if you click on download, this will redirect you to BIM Server Center.
and there is one more question. You can you see the chat, Chancelus?
Yes.
Okay.
I have actually, I believe actually modeling in 2D remains same as that in other softwares, right? Need to add member loads for masonry walls on beams and live loads on shells. Exactly. Yes. The sidecar, remember, was a 2D environment. The structure that I show in the first place about that Cype logo was created using a DXF DWG of our logo that I imported using this option of templates. One can very much add a DXF DWG template and snap that and start inserting. So yeah, I didn't demonstrate how to load because that would be a whole new other session, right? How to insert these structures that we saw. But here, if you go to project general data, you will find the ability to generate the load cases, and then to load the structure besides the loading, the seismic and wind loading. We have lots of ways. So for example, we have loads on groups. So whatever floors that we have created can be loaded entirely in all of their surface, adding live loads and dead loads. And one can also find the load menu in both CypCAD and Cype3D. So yes, they can be done in 2D. And here is where you will insert in Cype3D loads on bars or on shells. Here we find on panels. This model doesn't have shells, but the one that does have shells shall be available the enter loads on shells. So Yes, you can work in 2D or 3D in CypCAD only in 2D, but you can also see the 3D as we have been demonstrated at all times looking at the 2D view. And inside 3D, one can work either in a 3D view or in 2D. Um, how are the diaphragms assigned there? Okay, so diaphragms are considered automatically by CypCAD. Whatever we place on a floor, with in touch with a floor with a slab, is the diaphragm. Is considered automatically, and inside 3D we can have here diaphragms, and we can click here on assign, and we have to first edit and create one, say diaphragm D1, I'm going to call it. We would need to add the load cases, self weight, or whichever load case that we want to add it for, and then we select diaphragm and assign. There's a specific video about diaphragms on our learning resources. So one can create, okay, this node now. I don't know if you can see, maybe if we unselect the 3D view. I don't know if you can see that it's over the nodes that I have selected. In nodes, they form a diaphragm. So the diaphragm consideration will be taken into consideration. They would move only together. They cannot. If one rotates, the other parts rotate too, maintaining that diaphragm. Okay,
Do we have any other
thank you
questions?
so much for the questions,
Okay.
by the way. Thank you for all the questions.
Uh, I think we can wrap up the session. And Pawan, if you want to add something about the demos for the individual clients, if they are interested, and about the pricing and the discounts.
Yeah, sure. If any further queries after download the software in the trial period, we are here to support you. Yeah, sure. We will share the recording of this webinar as well. And if anybody want to purchase not a full module of a structure, any individual module, that can also want.
John, you want to add something?
From my end, I mean, I was just going to, if you, I mean, we know it was a very, first of all, thank you, Sonsoles, for your time, for everything. From what I was going to add was that if you, I mean, after this webinar of today, if you have questions as well, you can rely on Mr. Sandeep as well. I mean, he has provided his email and his telephone number. Okay, in case he won't be able to provide you with the answer as well. I mean, he has our support as well, so we are one team in the end. Exactly. There's you have the information for Mr. Sandeep. Anything related to SIPE, which you get with like pricing and the discounts, Mr. Sandeep will be taking care of as well. So that from my end, that's all. And thank you for making time. It's very important for us, and I will hope that you have found this session very informative as well.
Thank you everyone for attending and
Thank
for
you.
your time. Thank you very
Thank you.
much.
Mr. Sandeep, would
Thank
you
you
like to
very
add
much.
something from your
I have
end?
already shared my screen for my contact details. You can note it down and you can get back to me at any moment of time. We are there to help you out.
Okay.
Thank
Thank you. Have a good afternoon and have a good
Okay.
weekend and stay
Okay.
safe,
Thanks a
everyone.
lot. Thank you.
thank you,
Thank
everyone.
you.
Thank you, Mr. Sandeep.
Thank
Thank you,
you.
Thank
Santosh.
Thank
you.
you.
Have a
Thank
Thank
nice.
you.
you
Sure.
Thank
everyone.
you.
Bye bye.
Bye
Thank you.
bye.
Bye. Bye.